In this section, we're going to cover some of the data structures that .NET provides for you, and specifically, we're going to focus on collections. Collections are essentially classes that help you keep track of and manage a whole bunch of data. And since a lot of programming involves keeping track and managing data, it seems like this is a pretty good place to start. We're going to start off by looking at C# arrays. Now, in C#, arrays hold a fixed number of elements, all of the same type. An array is basically just a list of items and values. So, for example, if I declared an integer variable called oneValue and set it to be equal to 100, we've already seen this somewhere out in memory. The C# compiler and the .NET framework creates a little box called oneValue and puts the value inside that little variable box. Now, arrays are a little bit different than that, and the way you declare them as a variable is also a little bit different. When you declare an array, you specify the type that you want the array to hold. So here it's an integer, just like always. But then you put these two square little brackets next to the type definition. So you have the opening square bracket and the closing square bracket with nothing in it. And then you give it the variable name just as you always would. And this just tells the compiler, hey, we're not declaring one integer, we're declaring a whole bunch of integers. And then you complete the sentence by saying equals new, and then the type that you're creating, in this case it's an integer, and then inside the square brackets, you put the number of slots that you want to create. So this line of code right here, int, square brackets, many values, creates a variable called many values, which is an array of, in this case, 4 integers. And out in memory, what's going to happen is the .NET framework is going to create some space, and it's going to create a variable called many values, and there'll be 4 little boxes, all initialized to 0. The .NET framework takes care of initializing the array for you so that they're all 0. Now, arrays are 0-based indexes. So that first element of the array there is not element 1, it's actually element 0. And it counts up from 0 up to 3. So there's 4 elements, but it goes from 0 to 3. So if I wanted to reference one of the elements in the array, I would simply use many values, and then inside the square brackets, the index number of the one I want to change. So if I wanted to change the first element in the array to a value of 100, I would say many values sub 0 equals 100. And lo and behold, the value changes. If I wanted to change the last one, I would do many values and then 3 in the square brackets, and that works. Just like other variables in C#, I can also initialize array variables just like I can initialize other variable types. So in this case, I'm declaring an integer array called many values, and rather than creating the new memory using the new operator, I'm using curly braces and then just putting the array values inside the curly braces separated by commas. This will create an array of 4 integers, just like we saw in the previous example. And of course, I can do this with strings too. I can say string array, my strings equals, and then inside the curly braces, just 4 strings. One of the cool things about C# is that unlike other languages, like say Objective-C, C# provides what's called automatic bounds checking for arrays. So in programming, if you try to reference an array index that's outside of the bounds or the size of the array, some languages don't check that for you, and it can lead to code problems and bugs down the road. But in C#, if I tried to do this, many values, and then 100 inside the little brackets as an index, if I tried to set that value, that's going to cause an error. Why? Because there's only 4 elements inside the many values array. So there is no element 100, and that's going to cause a problem. The good news is C# catches that for you. Now, arrays are fixed in size. Once you declare them, that's just how big they are. There are other data structures that we'll get to that allow you to change the size of the array, but when you declare arrays like this, that's just how big they are. Why? Because this allows them to be contiguous somewhere in the computer's memory, which is very efficient for the processor to access and change them. The other thing you need to realize is that array elements are all the same type. So you can't have an array declared like you see it here that has numbers and strings and floats and different data types. When you declare an array using either int brackets or string brackets or float brackets or whatever, choose your data type brackets, they're all going to be the same type. Arrays can also be multi-dimensional. Now, in the previous example, we saw a single-dimensional array. It was just one list of numbers, but you can make arrays multi-dimensional. And the way that you do that is you declare the type, so for this case, integer. Then inside the brackets, you put a little comma. This is going to have 2 dimensions. And I'll have the name of the variable called multi-dim array. In this case, I'm saying new int and 3, 3. So that's going to make a 3 by 3 matrix of memory locations somewhere out in the computer's memory, and it's going to initialize them all to 0. And then to round out the picture here, the first number in the index there is going to represent the row number, and then the second number in the index represents the column number. So if I wanted to refer to a specific box inside the memory of the array here, I would say something like multi-dim array 0, 1 equals 10. And that means row 0, column 1, and that's the one that gets changed to 10. And just like other arrays, you can initialize these too. So to do that, I would have the int, the type declaration, along with my little brackets with the comma inside. And then I would just give it the variable a name. And in this case, I have new int, comma, with inside the curly braces, a set of curly braces, each one representing a row of data. This would create a 3x3 array with all of the boxes set to 0, 1, 2, 3, 4, 5, 6, 7, and 8. So you can initialize them, and you can make multi-dimensional arrays with set values. Now, arrays, of course, are, just like everything else in C#, objects. So, for example, if I had this declaration here for int many values equals 100, 200, and so on, that gives me an array object with 4 entries in it. So I can then do something like this. I can say many values dot and then call a function called getLength. And that will come back with the number 4 because it's how many there are. I can also call some static member functions. Remember we talked about static items earlier on. I can do array.clear and then give it the name of the array and a couple of indexes. Then starting at 0, it will clear out the 4 elements. I can do array.sort. It will sort the given array, assuming that the members of the array are sortable. Same thing with reverse. I can just reverse the given array. Because arrays are objects, you get access to a whole bunch of built-in features. So let's exercise some of these features. Okay, here in the code, I've got my arrays example open. And I've got my snippets here, scroll down to arrays, and here's my program code. So let's just go ahead and copy some of these over. I'm going to do the first couple of lines right here, and we'll paste that in. And here what we're doing is we're just declaring an array called many values that has a whole bunch of values in it. And then we're going to write out the value of the 4th number. And remember to do that, since it's the 4th number and it's a 0-based index, we use the number 3. You can see that right here on line 13. So let's hit F5 to run this. And the 4th number is 34. Okay, that's pretty simple, straightforward. Let's keep on going. In this case, we'll do the same thing with strings. So here I have an array of strings. I've got 4 strings. Joe Marini teaches C#. And what I'm going to do here is use a for loop to write out the values of each one of the elements. So I have a for loop going from 0. And notice I'm using less than 4 here, not less than or equal to, because it has to stop at 3. I'm going to write out each one of the strings using the I variable here to index into the array. So once again, I'll hit F5, and you can see that works just fine. Okay, so let's keep on going. This is getting interesting. Let's go back over here. I'm going to copy and paste this and put that down here. So here you can see that I've created an integer array called other values, and I've set it equal to many values. And now I'm changing the last item in the other values array to 0. But what I'm writing out over here is the many values array, or at least the last element of the many values array. Now, see if you can guess what's going to happen. If we look at the item here, you can see that many values sub 3 at 0, 1, 2, 3. It's currently 34. Let's see what happens when we change the other values array of sub 3 to 0. It gets set to 0. Why? Because remember, arrays are reference types. We passed in a reference to the array, therefore we actually changed the value of both many values and other values. And if you skipped the section earlier on value types versus reference types, you should go back and review it now. Let's try something else. Let's try some sorting. I'm going to copy this. I'm going to paste it over here. So now I'm calling the array class's sort static member function on my many values array. And when I do that, we're going to write out what the 4th number is. So let's go ahead and build that. And you can see that the 4th number is 16. So we sorted the array going from smallest to largest, and that's a built-in feature of .NET. Arrays are a really useful collection object to use in C#. You'll find yourself using arrays for all kinds of things. Arrays are used for processing lists of information and so on. But what we'll take a look at next is a collection type called ArrayList, which has some added benefits on top of arrays themselves.